Hey guys, so today we are going to be learning how to sample and how to graph that simulation sampling process. So, first things first, we read through our problem. And so this is a problem of getting diagnosed with cancer or having cancer, and then the probability of getting diagnosed with cancer, and then the probability of getting a false positive. So first thing we're going to do is we're going to simulate the disease status of 1,000,000 patients from the population and then simulate a diagnosis. We'll do some maths in between that, just figuring out the proportions and probabilities. I'll show you how to subset for proportions. Subset is really helpful when you're trying to just isolate certain variables. And then after that, we are going to make a plot using ggplot. So, as you know, the best and first thing to do is to upload tidyverse. Okay? Cool. And now we are going to make vectors for all the things we need. Like we want 1,000,000 patients. 1, 2, 3, 4, 5, 6. We want the probability of cancer, which is 1 in 10,000. We want the probability of getting diagnosed with cancer, if you have it. And that is 90%. And then the probability of a false positive, which is 1 in 1,000. Or it's 1 in 1,000. Right? All right. So, our cancer test, we want to make a data frame or a table, which will be helpful later. So from that table, we are going to create our first variable, which is cancer, spelled correctly. So cancer will be equal to a sample. We have to sample the population to see who has cancer and who doesn't. So X is equal to a combination of those with cancer and then those without cancer. The size of our sample is going to be equal to the size of the population. Then our replace value is going to be true because we don't want to change the probability each time we make a sample, each time we do something. And then the probability is the probability of having cancer. So the probability of having cancer is the probability of cancer, and then the probability of not having it is 1 minus that probability. Let's see if that worked. No, it didn't. Size, boop-a-doop boop. Oh, hello. I didn't insert any of this into the system. That would have been probably helpful. Wow, look at that. It worked. Fancy that. Now that we have created a simulation of our people with cancer, now we're going, ooh, that's not what we want. Now we're going to simulate a diagnosis. So we're going to come up, we're going to add to this data frame with the mutate function, and we're going to create our second variable, which is the diagnosis, which happens when, so for the diagnosis, you can either get diagnosed if you have cancer and then if you don't have cancer. So this is going to be equal to cancer, and you'll be diagnosed by the sample combination. You can either get a positive or a negative result. Size probability is the probability of getting diagnosed with cancer, because these people have cancer. The probability of getting diagnosed with cancer if you have cancer, and then the negative is this, of course. All right, and then we want to add in the false positives here, right? So this is when it's no cancer. This is set by, we can actually just copy this whole thing right here to save some time. And then this is the probability. If you get a positive diagnosis here and you don't have cancer, then this is probability of a false positive. Okay, and let's make sure everything lines up. And it's, oh, ooh, hello. And well, now it works. It just I guess it just wanted to be finicky, which is fine. All right, so haha, onwards and forwards. Now that we have added our diagnose variable, so we have made a simulation of diagnosing the population, either if that population has cancer and if that population doesn't have cancer, and we've also simulated, whether or not there's cancer. So on to the maths of this. So for proportions, we are going to want to subset our data. So we want the number of women with cancer. So the number of cancer from our simulation is going to be, you're going to want to count the subset. So count is a function that will just pull up the number. Subset is a function. So we subset. And boom. Sweet. So now we have the number of cancer, and then we're going to divide that by the total population. And we can call this whatever you want to call it. Prop. Proportion of people with cancer. Something that makes sense, obviously. And then we just want to find that number, which is, I guess we can view. .000105. No. And the probability of having cancer is just P cancer, which we know from earlier is 0.001. Pretty close. The number of, with the proportion of women with a cervical cancer diagnosis. So this is going to be very similar to this. You're gonna just want to subset the information. Some cancer equals cancer, except this is going to be diagnose is positive. And okay. 0.001099. The probability is it's the probability of women who have been diagnosed with cancer and have cancer. So that is going to be the probability of having cancer times the probability of getting diagnosed with that cancer plus the probability of plus the probability of getting it diagnosed with cancer even when you don't have it. Right? Yes. Okay. Yeah. Yep. Which is, haha, 0.00109. And this is the proportion of women without cervical cancer that are correctly diagnosed. So without cervical cancer. So we're gonna do this again. And these women are the ones who are correctly diagnosed. So n subset, except this is going to be minus, and you then use this handy D. And cancer is also equal to no cancer. Okay. Proportion of correct. So this is just n diag divided by that. Oof. And mm-hmm. 0.99889. Oof. And the probability of being correctly diagnosed is the probability of you not having cancer, so 1 minus positive, which was yeah, it's just the probability of not getting a false positive, which is 0.9999. Okay. And now we make a plot showing this, which we can just use ggplot. All hail the mighty ggplot. So, you know how to do this? Yes. So our x is going to be, for one of them, it's going to be cancer. Oops. So cancer? No, it should just be cancer. Phil is cancer. Geom bar. Oh, look at that. we want to use facet wrap to add in our diagnose. Add in our diagnose, and I'm gonna wrap it by the diagnoses. R Y to be free, or Y bar. There should be no limit to the scales, and labeler, which I'm not quite sure. We'll label both the graphs. Hopefully everything works out. Let's find out. Free Y, there it is. I don't know why I did this, you guys. It was just supposed to be a positive. Whoops. Boom. There you have it. So, all the people who have a negative response, none of them actually have cancer, versus all of the people with a positive response, a small proportion of them did, or a smaller, the amount of people that actually had cancer compared to those who got a false positive is much less. So yeah, thanks for watching. I hope that helped, and I'll see you guys next time.